Good afternoon, everyone. I invite you to take out your binder and get ready to take down a few notes here as we start to wrap up the things that we've been learning this week. And this does tie in a little bit to the end of last week as well. Okay, so we're going to recap, right? We've learned 3 different forms, and we're just going to recap those now. Okay, and again, to whoever's running the video, please just pause here and there to make sure everyone has time to copy it down as we keep going. So this is the first form, right? So a couple weeks ago, we started looking at vertex form, and the equation is y equals ax minus h squared plus k. As you recall, the information we can get from this is the vertex, which is h and k. And the a value tells us what the step pattern is, and it tells it if it opens up or down. The second form that we looked at is called standard form. Okay. So this is y equals ax squared plus bx plus c, right? And you get this form by expanding out the other types of expressions. Okay. And the information we can get from this equation, right, the last number there, c, is the y-intercept. Again, because the y-intercept happens when x equals 0, so if you plug in a 0 here and here, all you're left with is c. And the a does the same as it does in the vertex form, right? It gives you the step pattern and the direction of opening. Our third form is the factored form, which again we started looking at last Friday. So it looks like a, and then I have 2 sets of brackets, x minus s and x minus t. Okay, and the information that I can get from this form, okay, is the zeros. Okay, s and t, kind of the opposite, right? I see the negative there, so it's the opposite of what I see here. Those are my zeros, or x-intercepts. Okay, and the a gives you information about step pattern, right? So again, in all 3 of these forms, that opening number, right, a, okay, all those give us the step pattern and the direction of opening. Okay, now we've learned how to get vertex form basically from the graph. Okay, we've learned to get standard form by expanding out. Okay, so now how do we get factored form? Well, hopefully the name would completely give this away, right? If you want to get the factored form of a quadratic, you are going to need to do some factoring, okay, which is what we were working on yesterday. So for our first example, we're going to find the zeros for each of these quadratic expressions by determining the factored form. So our first expression, I'll cover up the other one for now, okay, is y equals 4x squared minus 16x minus 20. All right, so the first thing we're going to do, so remembering our different rules from factoring yesterday, okay, I have a 4 out front, so I'm going to want to common factor that out. Okay, so I'm going to set aside the 4. Okay, and that means I'm dividing 4 from all the different terms. So 4 divided by 4 is 1, so I'm left with x squared. Okay, 16 divided by 4 is 4. And 20 divided by 4 is 5. Okay, and again, a quick check, right? If I expanded this back out, right, I would have 4 and 16 and 20. Okay, my next step, now that I've got it down to this form, is I need to factor this trinomial, x squared minus 4x minus 5. So I'm looking for 2 numbers that are going to multiply to give me the last term, so minus 5. And they have to add to negative 4. Okay, so what are the 2 numbers? Okay, and again, I know some of you probably have them in your head already. Just to recap, if you're not sure, we should start with the 5. Okay, there's not much that multiplies to give us 5, right? There's basically 5 and 1. Okay, and then because it's negative 5, that means one of these numbers is going to be negative, because to get a negative, you have to have a negative times a positive. So either it's negative 5 times 1, or it's 5 times negative 1. Okay, those are our only options. Okay, so if I check now by adding, okay, what's negative 5 plus 1? Oh, that's negative 4. Okay, right, so this is the one I want. So that means my two numbers are negative 5 and 1. Okay, so my factors are going to be x minus 5 and x plus 1. Okay, so I've reached my factored form, right? I removed the common factor and I factored the rest of it. So now the actual question says, what are the zeros? Well, the zeros come from my factors, right? It's the opposite of what I see. So one of my zeros is positive 5. Okay, and the other 0 is negative 1. Okay, and those are my zeros, 5 and negative 1. All right, let's try B. Okay, so first question, what form is this in right now? Okay, if you don't remember, look back. We just took it down. Okay, yes, of course, right? That's the vertex form, right? Something squared, subtracting 8 on the outside here. Okay, so in order to factor, I have to be more in this form, okay, in the standard form before I can do any factoring. So that means I'm going to have to take this and do some work on it first before I can factor. So first we're going to have to expand this out. And take note, this would make a great quiz question next week. Okay, so the first thing we do to expand this out, right, is I remember that the squared means I have the same bracket twice. So I write that out twice, minus 8. Okay, my preference here is to do the distributive property on my two brackets first. Okay, you may choose to do it a slightly different way, but that's what I like to do. Okay, so first I have x times x. So that's x squared. Okay, second I have the x times negative 4. So that's subtract 4x. Okay, I have minus 4 again. So minus 4x. Okay, and last but not least, I have negative 4 times negative 4, which is positive 16. Okay, take away 8. Okay, next I'll bring the 2 in, so I'm going to double everything in that bracket. So I get 2 x squared minus 8x minus another 8x plus 32, take away 8. Okay, finally I'll collect my like terms. So there's no other x squareds, so I have 2x squared. Okay, negative 8, take away another 8. I have now negative 16. Okay, and finally 32 take away 8 is 24. Okay, so I've now reached the standard form. So let's note that in a second here, right? This is the standard form. So now I'm ready to move on to factor form. And it'll be the same steps as I had up here, right? First thing I have to do is deal with the common factor. So there's a common factor of 2. So I'm going to factor that back out. So 2. Okay, I'm left with x squared. Okay, 16 divided by 2 is 8. And 24 divided by 2 is 12. All right, and now we're finally ready to do the trinomial factoring. So I need two numbers that multiply to 12 and add to negative 8. Okay, so again, we'll start with what are some pairs of numbers that multiply to give us 12. Okay, well, it's positive. Okay, so we could do 1 and 12. Okay, we could do 2 and 6. Okay, or we could do 3 and 4. Those are all the different factors of 12. Now, when I look at the adding, it says it's negative. Okay, this number is negative, but this is positive. So that means they both had to be negative, right? Because negative times negative is positive. And if I add two negatives, I'll still have a negative. So I'm just going to put the minus signs on each of these. Okay, so my possible pairs are just the negatives of what we said before. So now, which of those pairs adds to negative 8? Okay, and while this is a close second, this is definitely the pair. Negative 2 and negative 6 add to negative 8. So the numbers are negative 2 and negative 6. So now my factors, I'm going to write x minus 2 and x minus 6. Finally, I'm ready to write what my zeros are. Okay, so I get negative 2. Wait, yes I do, and negative 6. Okay, no, I don't get that, do I? I'm doing that wrong. Zeros are 2 and 6. Positive 2 and positive 6. Okay, now, as a quick check here, if we look back at the top, this was vertex form, right? Okay, so my vertex right, I get that from these two numbers. So my vertex is positive 4 and negative 8. Okay, now remember, the vertex is centered between the zeros, right? My zeros are 2 and 6, and what's halfway between 2 and 6? 4. Okay, so I can be reasonably confident I did this correctly, right? Because my vertex should be halfway between my zeros, and the x-coordinate is halfway between 2 and 6. All right. One more example, and then we are all done. It's a little bit of a word problem here. We've been talking about kicking things in the air quite a bit lately. A football is kicked from the ground level. Its path is given by the relation h equals negative 4.9t squared plus 22.54t, where h is the ball's height above the ground in meters, and t is the time in seconds. Okay. How long is the ball in the air? Okay, so before we get into the algebra part, right, let's visualize this. Most likely, right, if this is the graph, right, it's going to be kicked off, leave the ground, and then come back and hit the ground. So the length of time it's in the air is from whenever it leaves the ground, here, to where it hits the ground again, which is over here. Okay, and so what are those, right? Those are basically the zeros. Okay, and yes, I could throw this equation into Desmos or something and look up where the zeros are, but I know that's what I'm looking for, so I can just try to get them from the equation. Okay. So we need to try to do some factoring. Okay, this is in the correct form to do factoring, so let's see what we can do. Okay, so again, first thing we always look for is common factors. Now this is a little weird because I have a decimal, negative 4.9. So let's hope that it divides nicely into 22.54. And I'm just going to bring up my calculator here and we'll check. So 22.54 divided by negative, oh, that's on the wrong number. Let's try that again. 22.54 divided by negative 4.9 is negative 4.6. Okay, that's not horrible. So negative 4 0.9. Okay, and over here I'm going to have a negative 4.6. Okay, the other thing to note here, both of these terms have a t, right? I have a t squared, and I have a single t, so that means I can common factor out t. Okay, so my first term I'm left with is that other t, and the t is gone from the second term. And basically we're done, right? There's no squared left here, so I am completely factored already. Okay. So what are my zeros? Okay, well, the obvious one is this one. Okay, I've got t minus 4.6, so it's the opposite of that, which is 4.6. Okay, my other one, well, it's just from this single t right here. So if I just have the t by itself, right, that means it's 0. Okay, so that means the ball left the ground at time 0, and it landed at time 4.6. So therefore, the ball was in the air for 4.6 seconds. All right, there we go. Okay, so again, that's basically the application, right? If for some reason I need to know where it hits the ground or what's the break-even point, that's basically finding your zeros. Okay, so that's it for the lesson. Okay, so one or two things you should be doing right now. Okay, if you want to practice this skill directly, okay, page 272 of your textbook, numbers 3 to 7, just parts A and C for all of those questions. Okay, there's lots of practice there, but bare minimum, kind of 2 of each would be good. Okay, or of course you have those 2 mini assignments that I gave out earlier in the week, right? 3C and 3D. Okay, one of which is all about factoring. So if you haven't started those yet, now would be a really good time to work on those, because at the end of tomorrow's class, Friday, you're going to be handing those in. Okay, so make good use of the rest of your time. Thanks for watching, and I'll see you in the future.